Now I'm very excited to call upon our next speakers for the day, Mr. Prajeesh Prathap and Mr. Raphael de Vienne, for presenting their talk titled DevSecOps, which is putting security in DevOps. It sheds light on the vital role that security plays in the overall DevOps lifecycle. So, saying this, let me introduce Mr. Prajeesh Prathap, who is currently working with the IT and Care in Netherlands as the head of platform and operations team. He specializes in setting up containerized environments, CI/CD using Azure DevOps, and observability platforms. So, welcome, Prajeesh. I also like to welcome Mr. Raphael, who is a very experienced security expert himself. He specializes in web security and reverse engineering and is definitely one of the better known hackers and researchers in the world. So welcome, Raphael. Over to you, speakers. All the very best.
Yes, I'm just going to do a quick check whether you guys are able to see and hear us.
Yes.
All right.
Awesome.
Perfect. Nice. So, good morning or good afternoon, wherever you're based on. For us, it is still good morning. I'll start with a small introduction because we already completed the checks of audibility and visibility. My name is Prajeesh. We both work for IT and Care in the Netherlands. I'm responsible on the job part. I'm responsible for the platform and operations in the company. To elaborate it, that means that together with my team, we make sure that the application developers can work with higher productivity, with availability of the latest and greatest technologies and industry set standards. So, yeah.
Yeah, I'm Raphael, technical security officer for IT and Care. And I work together with Prajeesh to secure every environment that we own and that we have, and to get a bit more grip on cybersecurity overall. As you have told in the introduction, I come from a history of hacking. Still a hacker by heart, but now I'm on the other side as a defending part and thinking along with Prajeesh to secure the the entire company.
Yeah, that was a slide. Well, one good thing about talking about security is that it is not unfamiliar with a lot of people, especially if you're working in information technology and something related to technology. Thanks to the news that you hear every day about security breaches and data being stolen and companies being asked to pay ransomware and things like that. It is like you almost hear this every day in your online newspapers or physical newspapers or news channels or whatever, right? And the alarming part is that this is not just confined to startups or smaller organizations, but actually tech giants like Microsoft or Apple or Facebook and Google are all victims of these breaches, right? So on that note, we can start our session. And when we were actually planning to have this DevSecOps conversation in this session, we decided that it's good to start with a security incident that happened in our organization, which I'm not really proud of, but if you look into the learning perspective of it, right? It's good to share our learning with the community so that not everybody has to make the same mistakes that we made, and then we can all learn from that each other, right? So it starts on a Friday evening on a weekend. And I think it was before the week of New Year's Eve or
it was,
something like that. Yeah, exactly.
Christmas, I'm not sure anymore. It's all vague.
It was something like that. So it was like around 6 o'clock, 6:30 or something like that, and I've shut down my workstations and I am getting ready for a relaxed, lazy weekend. Thanks to Corona, we don't have exciting weekends anymore, and I think I'm not sure. I was trying to have a glass of wine or planning to watch a movie or something like that. And then my office phone rings, right? So that could be only two things that can happen when your office phone rings on a weekend, on a Friday evening. Either it could be a maniac who is trying to play a prank on you, or it could be something serious. So I just picked it up, and then you are on the other side of the line, right? And Raphael, without any introduction, just not asking, you're not being polite, that sorry for calling the weekend and all those things. He just says that just shoots the question directly, and then says that, hey Prajeesh, are we using any log4j packages in our applications? And I'm like, log for what? Log4j. So I like say, what's going on? And then Raphael tells me that in the cybersecurity community, everybody is talking about this new discovered vulnerability in log4j that allows people to execute remote code execution on our systems, and then we can be attacked. So, well, okay. So then I was thinking that we are a company with good practices. We have continuous integration, delivery, version controlling, and all kinds of things in place. And so for me, I just went back. So I'm thinking that, if there is something that a package that is being used in our applications, it's very easy for me to figure it out. I just need to go to the repository, do a code search for this particular package, and then it appears in the feed, and then, okay, I can get back to you to say that. So I went back and switched on my workstations, and then I searched for log4j in our code repository. And then, like, in a couple of seconds, I got the list, and it was 0. So it says that there was no references of log4j in our application. So I called Raphael back, and they told that nothing to worry, it's all fine, we don't have any log4j. And then you say, no.
We do.
Yeah, we do. My monitoring systems are not happy, and I see that somebody is trying to exploit this vulnerability in our infrastructure. So that means that we do have log4j. Now, yeah, of course. So, yeah, to cut the story short, in half an hour, I think together with the platform team members, we are sitting in front of the system. And instead of having a glass of wine, I think I have a cup of coffee. That is really bad. So it means that you're preparing for a whole night to wake up. And we started hunting for these log4j packages and infrastructure. And yes, you were right. So we had these packages. So I think it took 2 days or something, right? Yeah. 2 days or something. The whole weekend is gone, and then we managed to mitigate this risk. And luckily for us, we were able to block all requests and things like that, and nothing happened to our applications or data. So we were happy. So after 2 days, we were like happy and
exhausted.
Yeah, exhausted, but still fine. Everything was fine. Work was, life was back to normal. But then, in my mind, I had a couple of questions to answer. Right. So one of the things I was not sure, and I wanted to get this answer, that why didn't my search reveal any of these instances of these packages in our application? Right. So, and how did this package sneak into our infrastructure, right? Today, if it is log4j, tomorrow it could be something else, right? So I need to know what is going on in my environment. When I deploy something, I need to know which packages are there. So I started digging, I started Googling all kind of things that the normal developer does that. And what I found is an interesting thing about modern software development. So if you look into my screen, this is just a sample code file from one of my applications. If you can understand C# and .NET, then this is very related to you. Otherwise, also you can still understand what's going on there. So in this code file, I'm doing a lot of things actually. So I'm configuring my message buses like Kafka. I'm configuring my database stores. I'm injecting dependencies and also setting up the routes to access my application and things like that. But all this functionality I'm able to achieve with very less lines of code. So there are like 8 or 10 lines of code which I've done to do all kinds of things, right? And how I was able to do this is thanks to this includes on top of the file. So what I've done is that somebody else, like a developer, has created some third-party libraries or code libraries, which does these things for me, right? So, and what I have to do is that I have to refer to that library, include in my project, and then I can make use of that functionality by just writing one line of code and invoking that library. So, which is really good because it increases developer productivity. So you don't have to create every or resolve the problem that somebody else has solved for you. So you can just use that library and use it. But what happens is that what I don't see over here is that when I refer to a third-party library like Newton Software JSON, that developer would have referred some other library, and the other library developer would have referred other. So it's kind of a recursive reference happening in your application. So when I see 15 lines of code over here, it's actually 15,000 lines of code, all these libraries and references and things like that. So the principle is that even though libraries and third-party libraries helps you to improve your developer productivity, it also comes with the caveat that knowingly or unknowingly, you are making use of a lot of third-party libraries that could be detrimental for your infrastructure. And if you are also using practices like infrastructure as code and containerization, when you say a software package, it is not just the functionality or the code that completes the functionality, but also you have Docker images, Linux containers, and Kubernetes artifacts, and service sidecars containers, and you have the CI/CD pipeline YAML files, and God knows whatever it is, right? There's plenty of things that comes as part of the software package. So that is like, so what I took away from this one is that when you deploy a software package into your infrastructure, it is not just one package, but it is like a software conglomerate. It's like a mix of a lot of packages in that software package. So now I found the problem. I wanted to have a solution for this one. So now I know that when I deploy something into my infrastructure, it is not just the direct dependencies which I bring into my infrastructure, but it's also the indirect dependencies. And this is exactly how Log4j got into systems. That it came through some of the Oracle clients package or something like that. So, and I was trying to see what is the solution for this one, and how do we get confident about what we are using in our infrastructure. And then I started digging again and Googling and all those things. And then I found that it's pretty easy. It's like we have tools to figure it out. So tools like CycloneDX, which we run it against your software package or your Docker image, it will go through all the references that your software uses, indirect and direct references, and it will generate something it calls as a bill of materials. So it is like a file, an XML or JSON format, which contains all this list of packages. So it's like thousands of lines in that file, which is kind of in a non-readable form because it's so many, it's a vast amount. And then you do have something like analysis server, which you can upload these files to. And that analysis server will compare this file with an online database, which has a list of all known vulnerabilities and risks and the packages. And then it will notify you if one of the packages in your software bill of material matches with a vulnerability known to the outside world. So then you get notified about it at a build time or earlier time so that you can react to it. And then you can fix it or you can remove it from your application.
So actually you're faster detecting vulnerabilities.
Exactly, I can faster be detecting. So now, then what I did is that I went ahead and implemented this one. So it is, I have shared a screenshot or a glimpse of how it looks, the analysis server looks like. So if you look into the screen now, this is my homepage of the analysis server, and then you can see that I have 6 projects uploaded over there. This is my demo server, so you want to see 6 months. But the interesting thing is that you can see the risk scores, and on the right there is the severities of each of these projects. So you can see that the first project has a risk score of 44, and there are some other risks. You can see that there are some severities with higher risk or critical risk or medium risk or low risk. And I can go inside this project by clicking on it, and then it will expose all the components that is used by this project. So these are the direct and indirect dependencies used in my project. And you can see it on the I highlighted it for you. But what is interesting for me is the vulnerabilities as part of this project. So you can see that I already have 7 vulnerabilities there, right? And if I click on that, it will list all the vulnerabilities with the appropriate severity along each of these vulnerabilities. Some of them are duplicated because that particular package has 3 or 4 vulnerabilities, which is immediately fixed, should be immediately fixed.
I love that.
And you can go inside this vulnerability again. So you can click on that package, and then it will take you to that particular vulnerability, which will give you an overview. What does that mean to you? So you can understand, if I deploy this package into my infrastructure, what is going to happen to my infrastructure, right? And then what I really like is it also comes with a remedy, so that I can apply this recommendation. So it says that upgrade this package, and then I'm done. So I've mitigated the risk. So in a nutshell, if I had this working when you called me, right, it would have been much easier for me to figure it out, right? So if you asked me to find out Log4j, I could have clicked on the component search, and then I could have entered Log4j in the search box, and then I could have searched for it, and it will list all the Log4j references if it was there. And not only that, I can click on that Log4j package, which will take me to the overview page to show me what are the problems with that. So if I had this one, and if you were to call me, I could have said that, yes, we do have Log4j. Yes, we have this particular version of Log4j. Yes, I know we have these vulnerabilities, and yes, I know how to fix it. But that was like, okay. So then I said, okay, we need to have this. Right? So this is one of the examples of having thinking about DevSecOps and security and all those things. And with that, I would like you to tell something about that.
Yeah, this is actually great, because like your example already told, sometimes it's a bit of a struggle, what to do when and how to search for what. And then the question rises: secure versus security, right? Security is something you think of like your first perimeter defense, like web application firewalls or whatsoever. But it's being secure means something else, right? Because hackers will hack always. So then do yourself a favor and think about what you could find, and think about what you as a attacker could do as damage, right? And DevSecOps and shift left actually means is implementing security more early.
Okay.
And doing so, it will greatly enhance the capability of you and me communicating, finding stuff, and being more early into the phase. Okay. So that is actually, it's your question. Do you know where anything comes in regarding security?
Yeah. So that's also something which I have in the next slide. So you were talking about bringing security early into the process of left shifting. We have heard this one. We also have this thing over there, which is good. And you hear this a lot, right? Left shift. It's kind of a buzzword nowadays. Left shift everything. Left shift security, left shift operations, left shift that, and things like that. And when before going into this left shifting mode or looking into where security comes into this picture, I just want to show what a process looks like, right? So a process for me, like it could be DevOps or continuous delivery, whatever it is, right? It is like the workflow of a software development team, right? So a typical software development workflow, iterative mode, whatever it is, right? It looks like this, right? They have different phases throughout their workflows. And it's not like a straight line, it's more like an iterative phase where it comes back and you plan again and things like that. But for the sake of simplicity, I just plotted it across a line with different phases over there. And you have phases like the planning phase, where the team sits with the product owner and talks about the requirements and plans when to fulfill this requirement in an iteration. then they go into coding, and they finish coding. They go, they try to apply these code changes on a continuous integration server to make sure that the latest code changes they have made doesn't break any functionality, and it works adhering to the standards that is set by the team. They can do some testing, and then they deploy and release the software so that the value is brought to the end user, and then they can monitor this in production for any problems or any user effect. So this is the normal workflow. And as a question, right, where do you think security comes into this picture? So if you have an answer, you can just put it in the Q&A or just tell us. So what is the thought, like in between which phase does security come in, or before or after which phase does security come in?
No.
Okay, to break the silence. Right? So if you have thought about security coming in, somewhere after the build process or before the build or during the coding or, a deployment, the answer is that you guys are all right? Because security actually doesn't come between or before any phase. It is part of all the phases, right? So this is interesting. So because it is right from the beginning to the end of your software development lifecycle.
Yeah.
So in the planning phase, instead of not only talking about your functionality and requirements, you can also think about, if we implement this functionality, what kind of threats does this bring to our application?
Yeah, well, I got something to add to that, because as you said, it needs to be implemented in every phase, right? So from start to finish.
Yeah.
And to make it a bit more clear from the attacker perspective and for the developer's perspective. So imagine just like a bit of a brain exercise, right? Yeah. So you're developing and you're trying to create code as beautiful and nice and secure as possible.
You think so?
Yeah, you would hope so, right? But implementing all those libraries, you never know. But whatever you're trying to do your best, and you have your PI plannings, your sprint plannings, and you just create something nice, your first and awesome stable MVP.
Yeah.
And then us guys come along, barge in, and say, well, we've tested your software and we found 21 vulnerabilities. Well, hell. Then you have to go back into the line and you got to redo the thing again, because you got to get it.
It's a security risk, so we have to do it in production. Right?
Yeah,
that's a problem with security.
Yeah, quite the problem. So what if you like you said, implement it in every phase? Then we're not the bad guys. You guys can just go on with the implementing phase and just the coding phase and thinking about more secure code while we communicate together and as a team, more as a team, instead of seeing us as an end gate, right?
Exactly.
So, and I think that is the most valuable part.
Yeah. I was thinking that when we talk about this threat modeling, right? So it is like you guys should also be part of that process. You know? Yeah. When a product owner or a requirement engineer comes and say that, okay, we need to create a payment gateway, and the developers are busy talking about how we can accomplish this, right? What kind of credit cards do we need to support, and how long we should wait for the transaction to complete, and if it fails, what should we do, and things like that. Yeah. And if you have security in this process, you will also hear questions like, how do we ensure that the credit card details is not getting stolen by a person like that, right? And then you will have these conversations around this topic also, which becomes as requirements of this user story.
Yeah.
Right. So maybe like you have to do it on encrypted wire or transaction protocol or something like that, right? And that is very important. So as I said, instead of you guys coming at the end of the software development workflow and checking and making sure that, telling us that, okay, we cannot release this because we have to first mitigate this problem. If you come earlier into the cycle, we can work together to define this as a requirement in our application. And if you realize this as a requirement, the good thing is that we can also create tests for this requirement to make sure that when we deploy into a production environment or before into any kind of environment or during our CI build process, we check whether this risk is mitigated in our software. And if it is not, then it breaks, and then we know each other. But I have a question, like, how do you find time? Because it's when I look into the composition, right, of the software teams, at least in our company, let's say we have a lot of software teams, and we have 1 or 2 security guys, right? So how do you find the time or the balance to be in all these things?
Barely.
No, how can we solve that? This is
it's good fun to say barely, but how do we find time is actually prioritizing what goes to the customer, what the customer needs, and making sure that what the customer needs is secure. So that is a high priority, right? Because here internally, we make use of servers and services and software, but when we publish it, we need to make sure, also according to law, that it is secure. So in my schedule, you guys will get priority over any other thing.
Okay, thanks.
Yeah.
Good to hear that.
Yeah.
Okay. So to continue with this process, after you do the threat modeling, then you can go while coding, you can also have certain code reviews and best practices to implement. Like, for example, you can make sure that your code doesn't support SQL injection, and things like that. And then in the build phase, you can have tools like the software bill of material, which I showed you earlier, to do or do some kind of vulnerability scanning with static code analysis. And after you deploy, you can also do certain tests like OWASP scanning and things like that. And if you have the proper tooling around your infrastructure, you can constantly monitor your applications for a particular security posture, like CIS policy and all those things, and then make sure that your application is unhackable or whatever it is. And if somebody tries to do something, or if a new code change breaks one of these policies, you get notified and alerted, and your application is safeguarded. So for this session, according to me at least, this is the most important slide. So this is the salient slide. I want to bring it up, right? And the message is that instead of thinking security between or before any process, actually it is coherent of every phase in your software development lifecycle. And I just have also some kind of screenshots from our applications or pipelines to show how it works. So this is like a screenshot from our our CI pipelines, and you can see that this is a build process, and I highlighted the stage where we do security scanning and secure static application code analysis. So you can click on that particular stage, get more insights into your pipelines. So you click on that, and then you can see that you have steps for credential scanning and Sonar Cloud analysis and things like that, which will push this analysis report into a cloud server where you can go and see what kind of vulnerabilities you have, or what is the security posture of your applications. You can dig deeper by clicking on that particular detail, and it will show you from which code file, what kind of vulnerability you have, who has pushed this code into the build environment, and then it also probably shows you the remedies for that. So you can do this one, like as I said, this is done on the build part. And in a release or deployment phase, you can run your dynamic security test, like OWASP scanning. And you can also get details into that one. And this is something which I have pulled it out from a software called Bench, which, as I said, which evaluates your security posture against the CIS policy. So you can see that it runs these security checks on my deployed applications or my containerized environment and lists me all the fails and warnings and passes. Where it is like kind of looking like a console now, but if you have proper log forwarding and aggregations implemented, you can also put it into something like a Grafana or Kibana dashboard and get more details and graphical visualizations of it. It's pretty easy to do. So the takeaway is that consider security as a process that comes as part of every phase of your software development lifecycle, and bring in tools that you think can solve certain problems in that thing. So don't just blindly implement these tools, but Jill, based on your technology and tool stack, you find out what are the problems that you want to mitigate and what tools work for your cases.
Yeah, indeed. Yeah, hackers gotta hack.
Yeah, I don't like
We
it.
always do.
I hate you guys.
I love you. I love you. No, the importance of a hacker's mindset, because, like you told, is talking about implementing security within every phase, right? But that means that you guys also need to think about having more security knowledge. So thinking about your implemented code, think about your copy-pasted code or whatsoever. I'm just making fun of you guys. Think about your hard work, right? And what I'm trying to say with it is you gotta try being a hacker. So in every phase, you gotta think about what can a evildoer do with my code, and can it be hacked? Can somebody abuse what I've created? While doing that, you got to start somewhere, and most companies have security guys within their company. And like you said before, we need to communicate a bit more. We need to cling together and learn from each other, and that is where the multidisciplinary work starts. Because your work is not only programming anymore, but your work is also a bit of security. That is also due to shift left team.
And is this the red and blue green team strategy and things like that?
Oh yeah, for sure. Yeah, because you guys, we're trying to attack your code, right? And you're trying to defend your code. So in essence, we're playing red team and blue team. But by doing that, we keep each other sharp. We teach each other the new tricks and tips on security. You guys perform better. I perform better because I really know what you guys are doing, and you really know what I'm doing. That means that we are more integrated into our work.
And what is the recommendation? How often we should do this kind of workshop?
Well, bi-weekly even, because or even monthly. I don't really mind as long as you're doing it.
Maybe it starts with a high frequency and then.
Yeah, for sure. Whenever everybody's up to speed, when everybody has the basic knowledge of being a semi-hacker, so to speak. So a semi-breaker of your own code. So that in that way you can in your case you can create a defensive line through offense, because you're always thinking about what could a evildoer or a dude like me do with the code. Could he abuse the code? Could he inject some nasty code into it? So I think that's really important of our roles clinging together within the organization, showing what we can do to the and for the organization.
Okay, and so because these workshops cost time and energy and revenue also, right? I'm just wondering, how do you measure the return of investment on these things? Because you're asking the time from the development team, and it's like the whole development team coming up. So as a if I'm an IT manager, how do I justify the costs behind this one?
Well, it's hard. It's hard to measure what's going on that stage, because security is actually something. It's a good one actually, because imagine yourself, right? You're living in a nice home. You have probably a lock on your door, and you will lock it every night. Nobody has ever broken into your home, but you know by best practice that you need to lock your door. So how is that measured? How is it measured? By locking your door that nobody will break. That's the same with security.
Yeah, it's like an insurance policy, right?
Exactly. So you don't want to get hacked, but you do want to produce safe and secure code, right? And by doing so, you will see hopefully lesser attacks, because from the start until the end, security is implemented. And that means that the same for your house. And
I will not get calls on the weekend.
No, well, it's also, I like you manage, because like you said, it's hard to manage the challenges and solutions, right? And you talked about a bit of tooling. So the tooling regarding the entire the entire pipeline of developing. And as you showed, you're using many tools, but many tools have many outputs. And like we're trying to do is create a smarter flow of outputs. So instead of like, for instance, when you're doing a static code analysis, with a static code analyzer tool like checkmarks or whatsoever, it will produce a lot of false positives.
Yeah, I've seen that one. That's really annoying.
Yeah.
And that's something which also, as I said, it works opposite, right? So
Yeah.
you're using these tools to get faster feedback.
Yeah.
And get some insights into what's going wrong or
Yeah.
what's going good. But then if it comes with this kind of the plethora of like so many false positives, like if you run
You'll
this
get
tool,
tired.
yeah, I'm not just getting tired. I'm just like kind of lost because I don't know when I run and see like 3 or 4 issues.
Yeah.
I know I can plan this, I can solve it and all those things. But when I run and see like thousands of issues,
Yeah, it's undoable. You got to check it by hand. You got to recheck it again. But like you said, it is human versus automation, right? So in this case, we're having, like, for instance, checkmarks. No offense against checkmarks, but you will get a lot of false positives out of it, and you will grow tired, or even do not take security that seriously because it will have a lot of false positives. And by doing so, you can think how to solve this problem, how to speed up this problem with the intelligence that you've already built into your pipeline, right? So what if you gather all the output, rescan it with a dynamic code analysis tool, or even rescan it with OWASP or with any other vulnerability check tool, and just build in a smarter flow to check, automate the checks one by one, maybe nightly, so that you don't have to, and that it gets validated more faster and even more accurate than you could do on a daily basis, because it's a lot of false positives. And I think that is the most important lesson, is what do you do with the output of security? Do you follow it up, or do you ignore? When it has a false positive list, you will ignore probably more or less, because it's a really tedious job. And by doing a smart analysis on what you see, then you will get a more secure environment.
And I don't know whether you're aware of this, because I'm also a big fan of the new technologies like artificial intelligence and machine learning and things like that, right? And security is also benefited and also being compromised by these kind of technologies coming in, right? So cryptography is getting weaker, let's say, for example, but then you also get the support of these tools like checkmarks probably will have some kind of a machine learning algorithm behind it to detect these false positives and then not report it in the future. Where do you think the future of this is going on?
Regarding that, I think it has a long way to go, because we as humans are freakishly smart. We are creative, and a simple statement as it being used in AI cannot overtake us yet. So we still need each other in that sense. So we need the AI to speed up.
And for my job security also, right? I don't want an AI to write the code.
No.
It is started.
Tesla has some nice stuff.
Yeah, Tesla is also implementing it. They're working on this software 2.0 concept or something. So, it's so nice.
I like it. Okay. Right. But it's good fun to see that part, and turning AI into a solution for us for getting more results out of it without overthrowing ourselves would be a good one. And I think that's the main goal for us, is to speed up the process, like with left shifting. Speed up every process, including security and development, without annoying each other, without getting in each other's way while the train has already left to the next station.
I think we can leave a lot of room for questions.
I think we can. There might probably be a couple of questions, and if there are, so please put them in the Q&A. feel free to ask anything except our personal information. It's already there. So no worries.
It's kind of selling yourself, right? You went one step ahead of putting everything on there.
Yeah, indeed. So we made it easy for you, so you don't have to do anymore.
So like us. Yeah, thank you very much then.
Yeah.
If you have any questions, just put in the chat.
I see a big smile there, so I think it's all good on there, and I think you guys have had a good time.
Yes,
We did.
definitely. It was really heartwarming to see you all smiling, laughing, and also telling a lot about security. So
Some reason for in this this pandemic situation.
Exactly. So thank you, Mr. Prajeesh and Raphael, for this wonderful session, giving us some really nice, valuable insights. So thank you once again for joining us.
Thanks for having us. So if you have any questions, you can leave it to the chat or send it to us through email or contact us.
Sure. We'll do that. Definitely.
Thank you.
Bye-bye.
Okay. Bye-bye.
Ciao. Bye.